Hi everyone, welcome to iSignal channel. So in the previous video we have seen related to the eNodeB log configurations, and in today's video as I promised, so I'm just going to discuss about the eNodeB logs. As you can see, so it will be a result of the L3 call. Whenever the L3 call is actually ongoing, then we'll try to capture in the UV side also, in the base station side also, in the EPC side as well, because this is a part of an LTE L3 call. So today we'll try to see about the eNodeB logs, but basically it is a very huge log. In order to understand it takes a lot of time actually. So that's why I'm just trying to put in a very simple way, because we see multiple layers, basically RRC, MAC, communication, COM port and RF, and also S1AP, right, physical layer, MAC, RLC. So all the logs are there. It captures all the logs basically. But here, in order to get the look and feel how the different layers have been involved, and in order to match with the L3 call, whenever an L3 call is ongoing, what are all the different things that we can encounter, whether this is following 3GPP compliant or not, right, with respect to 36331 or 304 or whatever the specifications that you are familiar with. So the prerequisite is you should know just basics about the RRC and the basic L3 call. Maybe if you're from the testing background or from the development background, that is also fine. But this is basically from the development perspective, whatever the things have been captured with respect to the L3 call in the eNodeB. So these are the things that we can see much more in detail. I'll try to give a glance view. Maybe we can revisit again these logs again to understand much more in detail. So to start with, this is basically without hardware. There is something called a ZMQ, which is 0MQ, virtual imitating RF, which means TX and RX will be happening with the support of this library, which means there is no hardware actually required in order to uh, test the L3 call. So that is what the software, whatever I'm having. Thanks to SRS RAN, they're giving very good insights related to this particular software, and mm, giving a much more detail in order to understand in this way. So if you try to have a look at to the RRC, so first of all we have system information block, right? If you try to match, then we'll come to know, if you are familiar with L3 call conceptual understanding from the domain perspective, maybe you can watch the my LTE videos as well with respect to the RAN protocol development. So I'll try to go through some of the things. RRC is there and S1AP is there, right? This is for the MME connection and communication. This is for the port communications, SCTP communication, and S1AP, right? RF communication. Then later we are slowly moving for the MME connection. Once the MME connection is done, right, procedure is completed here, then we are initiating the cell initiation. Means now the base station is actually connected to MME. Now base station has to broadcast or initiate a cell and start broadcasting the information. Broadcasting is already done here. So then this call talks about one UV connected to a L3 call. One UV connected to L3 call. So that is the main thing here. So as a part of that, in order to understand those things in detail, you can see physical layer also is there, starting with the physical layer thread, right? This is 50. Number of pair is 50, which means 10 megahertz signal, right? And this is subframe length, which is 11520. Okay, MAC came. So now once this is done, it means that the expected is SIP1 and SIP2 is uh, already broadcasted, and also UV is already taken and decoded and everything is ready. Now UV has to initiate the preamble, right? So this is basically 5 receiving, because UV is sending, because this is UV eNodeB log. So in this you can see the PRACH preambles. Basically the preamble selected is 45. Now the RNT allocated is 46 by the base station, right? The scheduler is deciding and taking it. So and allocating the 46 as the RNTA, which means random access is successful, and the allocation of RNTA is 46. This is just a preparation actually. Okay, so the radio barrier, LCD 0, transparent mode. So once you are familiar with the domain knowledge, then it is possible to understand these logs much more in detail. Otherwise, it is very difficult. First of all, we have to understand the 36321, which is MAC, right, which talks about the random access. So I'll go through these logs in multiple series so that it will be easier, and please try to follow in sequence to understand the MAC. Okay, so MAC and all the other layers as well whenever it is necessary. So RACH is there, TTI is 341, component carrier is 0, PCI is 1, preamble 45, right, temporary CRNT is 046, scheduler, random access, now it is actually sending the random access, right. These are all the DCA and the grants RNTA for this particular RNTA, and this is the MCS, because we are not required to know, so I mean we are not required to make the UV to access much more MCS basically. So CC is there, aggregation level is there, resource indicator value, right, and HARP process ID, MCS, new data indicator. This is completely DCA information, right. So DCA, which means the data, sorry, downlink control information. So pushing PDU, right. So today we will discuss only about the until the RRC connection. In the next video we will try to see the other details, right. RNTI, because this is E node B, majority of the time we will be having a look at the multiple layer specific details in the inside the E node B, not communicating to MME. So PDCP is there, MAC is there, allocate SR resources, which means the scheduling request, and allocate CQI resources. This is for the reporting of the CQI, right. This is done by the RRC layer. And scheduler or contention resolution identity, if there is any contention, right. In this particular case, contention seems to be existing. And PDCP, right, for the SRB, because you are about to get connected, which means RRC connection complete is supposed to be done, right. So that's why you can see here SRB 0 PDU RRC connection setup, which means 20 bytes. It means if you are decoding this, then you can get 20 bytes. If you are decoding this, then you can get, I mean the data means RLC configuration, PDCP configuration if existing, right. All the configurations will come into the picture, which means it is a dedicated mode of configuration that is being sent in the RSA connection setup, but still it is going in the SRP 0 as well, right. So queue size 1 and other things you can see, 046, mask, DCI, right, whether it is a transmission or a retransmission, control format indicator, this indicates the PDCCH symbols, and transport block size, which is 32, right. Number of control elements, contention resolution ID, in this particular case is a control elements. So like this, whatever required from the scheduling perspective, and PDCCH and PDSCH, right, you can see all the things are actually sending by the base station as a DCI, right. MAC, physical layer. Finally we are coming to the RSA connection setup complete. So in this, until this point, right, RSA connection setup complete. So whatever the things are required, or whatever the functionalities are required, here you can see the PDCP and RLC side also. For example, you can see RLC SRB1 RX data PDU, right, with sequence number 0. If you decode this, then you can get proper data. We can get proper data according to the rules of RLC that has been specified in 36322. Okay, so encryption, and finally we will get RS connection setup complete. RSA connection setup complete. Okay, so we'll stop here logically, and then we can continue in the next video to start with the health recall. So we will start from here. Okay. Thank you. Let's have a look at into the next video, coming video.